We will update that, and in the response here, we will say result is equal to true. That is apply coupon. Copy that, paste it one more time for remove coupon. When we have to remove the coupon, we will empty the coupon code, and perfect, that looks good. With that configured, let me run the application and see if that works. When we are retrieving the cart, we are using the user ID that you can see here. So let me switch back to the database here, copy the user ID, open the shopping cart API, and apply coupon. Try that out. I do not need anything with the cart details. So let me remove cart header altogether. The product here, we don't care. The only thing, user ID, coupon code, let me say 10 off. If I execute that, perfect, it is successful. Let me go to database here, and we have 10 off. Let me try to remove the coupon. Copy the body here, go to remove coupon, try that out, and we will remove that. Let me see that. Perfect. Now of course you can integrate the apply and remove coupon in the same logic by passing an empty string if you want, but I am keeping things different for now. With that configured, let me continue from the next video. As I mentioned before that we can integrate the apply and remove coupon in the same logic. Let me delete the remove coupon and I will only keep apply coupon. When a user is removing a coupon, we will pass the same cart DTO, but we will pass an empty coupon ID. That way it will automatically clear that. But now we have one more thing. When we are getting the shopping cart here, we are populating the product here. At the same point, if the coupon code is available, I want to go to the coupon API, get that coupon code, retrieve what is the discount that they should receive, and apply that and modify the cart total right here. For that, we have to implement coupon service. Let me scroll down where we have the product service, copy and paste that here, and I will rename that to be iCoupon service. Let me modify the class name, and what will be the return type? We will only retrieve one coupon. So the return type will be coupon DTO, and we will say get coupon. We will pass the coupon code. Let me implement the iCoupon service. Inside service folder, add a new class. That will be coupon service, and it will implement the iCoupon service. We will have to use the iHTTP client factory. Let me paste that, and I will copy the product service. Let me copy all of that, paste it inside the coupon service. Perfect. This time we will be creating a client with the name of coupon, and I will configure that in the startup project in just a minute. But where we have the get async, we want to call the API /coupon. Let me go to coupon API. We have the API /coupon, and then we have the get by code. Copy that, paste it here, and then we will pass the coupon code. Let me add the async keyword here. Perfect, we read that back, deserialize that as response DTO, and we will deserialize that again in a coupon DTO. Perfect. The else part here, we will return a new coupon DTO. Perfect, our coupon service is looking good here. Let me edit the project file here. Well, I want to go to the launch settings.json file, and the port number is 7001. Let me add that inside the shopping cart, app settings. I will add coupon API, copy and paste the path. That will be 7001. Lastly, I have to modify the program.cs, inject the coupon service, and we have to register the HTTP client with the base address. Name here is coupon. That is what we have used. And this will be coupon API. With that, we have configured or added the coupon API. We can close everything here. Let me open the cart API controller and I will inject the coupon service. Perfect. After we have retrieved the cart details here, we will add the logic to apply coupon, if any. We will have to check here. I will add a not sign, string.isNull or empty. If cart.cartHeader.couponCode is not null or empty, then we can try to retrieve that coupon from the coupon service. Coupon DTO coupon is equal to await. On the coupon service, we have getCoupon. We will pass cart.header.couponCode. That will retrieve the coupon. We can check here if coupon is not null. And we need to make sure that the cart total is greater than minimum amount for a coupon. So cart.cartHeader.total that we have must be greater than coupon.minimum amount. If that is valid, then we will subtract the cart total minus equal to coupon.discount and I will also populate cart.cartHeader.discount is equal to coupon.discount. With that, I believe everything looks good. Let me run all the project here and see that in action. Let me go to SQL Server and let me examine the coupon table that we have. We have two coupons, 10 off and 20 off. Let me go to Shopping Cart API. We need the user ID here. Let me go back. And where is that? We have the user ID and there we do not have any coupon. So first we need to apply a coupon. Let me try that out. We only need the user ID here. We don't care about anything else. Well, the coupon code. We will make that 20 off here. Remove the cart header. Product. Execute. That is good. Let me go back to the database. And perfect, the coupon code is applied. Let me try the get shopping cart. I need the user ID for that. Copy the user ID. And let me see. Okay, we have an error in the get coupon and we have unauthorized. We have the unauthorized here. Let me continue. And for now, let me add a manual hack in the coupon API. Remove the authorized keyword and run that one more time. Now again, this is temporary. We will fix that very soon. Let me try the get here. Enter the user ID. And perfect. We have the cart total here. You can see discount is also populated. That means that the shopping cart is retrieving that coupon. It knows it has to give $10 of discount and then the order total is 412.62. If I go to my database and let me try one thing here where we have the shopping cart, cart header, edit that and let me give that a different coupon code of 10 off. If I go back to the API endpoint, the total was $412, but now with 10 off, it should only give $10 of discount, so it should be $422. And perfect, that is exactly what we see. With that, we can see our shopping cart can consume both the product services as well as coupon service. With that, our shopping cart service is consuming both the product API as well as the coupon API. Now we are on the fun part. We want to consume our new service for shopping cart in the web project. We have to add that URL. If I go back to the presentation, shopping cart is 7003. Let me double check to make sure that I modified the launch settings. Yes, that is 7003. Let me copy that. And here I will add one more. That is shopping cart API. And I will add the URL there. Perfect. Then we need the utility folder, static detail. Let me add that constant here. That will be shopping cart API base. Configure that in program.cs. Copy and paste it. We have the shopping cart API base and shopping cart API. Then let me add the service. In the services here, let me copy the iCoupon service, paste that. I will rename that to be cart service. And let me also copy the implementation, paste that here. That will be cart service. Let me work on the interface here. And let me copy the name, paste it here. Perfect. What will be all the methods that we want here? First one will be to get cart based on the user ID, and there we will pass the user ID. Then we want to add something to the shopping cart. We have the upsert method. I will call that upsert cart async, and there we have to pass the cart DTO. Now we do not have that DTO in the web project. Let me add that. I will go to the shopping cart, models, copy the cart DTO, paste that in the models of the web project. I also have to add the other DTO. Let me do that. We have cart details and cart header. Paste both of them here, and let me modify the namespace mango.web.models. Copy that. Modify all the namespace here. And perfect. That looks good. We do not have any errors. Let me close all the DTOs that we have open. And let me work on the DTO. Perfect. Upsert looks good. Then we have the method to remove anything from the shopping cart. I will call that remove from cart async. For that, we are only passing the cart details ID. Let me add that. And finally, we have the logic to apply coupon. That will be task of response DTO. I will call that apply coupon async. And there also we are passing the cart DTO. I believe 4 of them looks good for now. Let me go to implementation of the cart service. Let me copy the name here, modify the class name. Perfect, that looks good. Let me implement that interface. We have the apply coupon. Let me cut this here, paste that. That will be a post, that is fine. Make that async. Data, we will pass the cart DTO. And then we need the URL, that is API/cart. And let me double check. We will go to the cart API, API/cart. And let me go to the action method. We have apply coupon. Copy that, paste it right here. Apply coupon looks good. Let me remove everything else here. Right here we have the get. Let me cut that and paste it inside the get cart by user ID, add the async keyword, and if I go to the controller here, we have the name of getCart, copy that name, and I will add that right here, /, and then we need to pass the user ID that we receive in the parameter. We need to change the static detail here. That will be the cart API base. Let me modify both of them. Perfect, that looks good. Let me remove everything else that is related to coupon here. Perfect. Now we have the remove from cart async. Copy the post 1 here. Paste that for both the methods. And add the asynchronous keyword. Let me examine the remove from cart async. Where we have that, we are passing the cart details ID. Let me go back here. We get the cart details ID. We have to pass that with the post data. The name here, let me copy that. It is remove cart and paste that. Finally, we have the absurd cart async. Let me go there, copy the name, paste that here, and we are passing the cart DTO. That looks good. With that configured, the cart service is looking good for now. Let me open the program.cs of the web project. I need to configure the service here, so let me copy and paste that. For HTTP client, I have the iCart service, cart service. Similarly, we will have the scoped implementation for the iCart service. Perfect. That looks good. With that, we have added the cart service in our project and configured our application with program.cs file. That looks good. In our web project, we need to add a controller for the shopping cart. It will be an MVC controller. Let me call that cart controller. And there we have to inject the cart service. Let me do that with dependency injection. The index action, let me modify that to be cart index, and we will make sure that this is only accessed by authorized user. Return type here, make that async, task of action result, and there we have to call the cart service, and there we have to call the cart service based on the logged in user. But rather than adding all the code here, let me create a new private method right here that will return a type of cart DTO at the using statement, and I will call that load cart based on the logged in user. Then where we have the index view, we will return whatever this particular method will return back. That will be a cart DTO. Now let me work on this method. All we need to find here is user ID of the logged in user. We can get that from the logged in user. We have added few claims. There, let me add a where condition. I will say u goes to u.type is equal to. If you remember, I added the JWT registered claims .sub. That subject will have the user ID. I will call first or default on that .value. Let me hide this here, and perfect. That way we will retrieve ID of the logged in user. Once we have the ID, calling our cart service is super simple. We will say variable response is equal to await cart service dot get cart by user ID, and pass the user ID. We will get the response back. Response will be of the type response DTO. I can modify that here. Perfect. After we get the response back, we can check if response is not null, and if it was successful, then we want to populate a cart DTO. We can say cart DTO is equal to, we will have to use JSON convert.deserialize object. The object will be cart DTO. That is what our API will return back. And here we have to convert .toString the response.result. Let me return back the cart DTO, and if it was not successful, we will return a new cart DTO. With that configured, let me add a breakpoint here, and I want to see that in action. But we do not have a shopping cart. Let me add that in views, shared underscore layout, scroll down. After the drop down here, let me copy one more li element, and we will add that right here. Controller name will be cart controller, and action name is cart index. Let me copy, paste that here, and rather than typing something here, let me add the bootstrap icon here for shopping cart that has the class of bi-cart. We have added everything that is needed to load our shopping cart. Let me run the application and see what happens. We will encounter an error message, but let me show that. Let me open the web project here and let me log in as an admin user. If I click on the shopping cart, we will see error message because the view does not exist. So let me go here and add a debugging point in the response, and let me click on the shopping cart, examine what the response is. If you notice here, you will see not found. I want you guys to pause the video and analyze on what is wrong. I have intentionally left an error in the code, so try to figure out on what is causing this error message. Make sure to pause the video and debug the application. I hope you have figured out what the issue is. But if not, let me do that together. Let me continue here, that is okay. Let me add a debugging point in the base service. And before we send the request out, right here, let me press enter. Press F5 to continue here, and let me examine the message that we are sending. If you look here closely, you can notice that we are going to API/coupon and get cart. This cannot be coupon because we are going to the cart API. That should be API/cart. Stop the application and let me remove the debugging point first. And let me examine the cart service. Where we have the get cart by user ID, I left coupon here, and that is why we were encountering not found. Once you fix that, if you run the application, you will no longer see the not found. I'll have to add the debugging point again here. Let me log in. And if I click on the shopping cart here, perfect, it hits the endpoint, but in our shopping cart, we do not have any entry for this user ID, so it will ultimately throw an exception and return a null shopping cart. Let me continue here. It goes into exception. I had a debugging point there. And if I examine the response here, you can see sequence contained no element, and then it returns a new cart DTO. Before we continue on here, let me work on the logic to add something to the shopping cart. From the home page, if we go to details, we have add to cart. We want to make sure that when we hit the add to cart here, we call our cart API and add item to the shopping cart. Let me work on that. I will close the application. Let me close all the tabs here. We will work on the home controller, and there we will have to inject the cart service. Let me add that with dependency injection, and we have the product details right here. Let me copy that and paste it one more time. It will be HTTP post. Let me add that. And along with that, let me add an action name here to give that the correct name, that is product details. Whoops. There we go. That looks good. Now when we are posting here, we will receive a product DTO. Let me add that. If I go to the view here, we have the product DTO that will be posted. In the view here, we do not know which product it is. For that, we will have to add that in a hidden property inside the form tag. That way, when the form is posted, we get the product ID. Based on the product ID, we will have to populate the cart DTO. Now, cart DTO contains cart header and cart details. First, let me create that cart DTO here. And there we need to populate the cart header. That will be a new cart header DTO. Inside there, I want to populate the user ID. I can get that from user.claims.where, and I will add u goes to u.type is equal to. We need to get the subject. When we were getting the subject before, we used some other constant, but we can also use the JWT claim types that is inside identity model. We will say JWT claim types dot subject, and that will retrieve the user ID as well. When I am programming, I like to show you the different workarounds or different options. That way, you have multiple ways of getting the user ID. Now we have populated the cart header. We need to populate the cart details DTO. That will be a new object. There we need to get the count. That will be inside product DTO.count. And then the product ID. That will be inside product DTO.product ID. We have that in the hidden field. We scroll down here, we have the input for count, and that should populate the product DTO.count. Finally, we need to create a list of cart details DTO. Call that cart details DTOs is equal to new. And there we will pass the cart details. Let me call this cart details. And perfect. Now this cart details DTO, we can assign that to cart DTO. Whoops. Cart DTO dot cart details. Perfect. That way we have populated header with the ID, and inside details we added one entity where we have the count and product ID. We have to call the response here, but that will be on the cart service. We have the upsert method for cart async, and I will pass the cart DTO. If the result is successful, we can redirect them to the index page. So return redirect to action, and I will say name of. We have the index action. Before I do that, let me display attempt data for success. And I will write item has been added to the shopping cart. Perfect. If it is not successful, we return back to the view with product DTO. And that looks good. Let me run the application and see if that works. We will log in here as admin. Let me try to add count of 4. Perfect. We can validate that by going to the shopping cart here. And we had that query right here. Perfect. New entry has been added, and that looks good. If I go back for the same product, if I add one more entity, count will be 5 now. That is great. If I add some other product, quantity of 3, it will add one more row in the details, and perfect, our add to cart is looking great. If we click on the cart here, it will retrieve the shopping cart. Let me see the result here, F5, and perfect. It has 2 cart details, so that is also working as expected. In the next video, let me create the cart index view to view the shopping cart. We need to add the cart index view. Let me close the application here, where we have the home controller. Let me close everything else. Well, I have to work with the cart controller. I will right click, add the view, empty view, and the name is cart index. Add that. Now for the designing, I have provided that in the snippets. If you go to the snippets, section 9 folder, we have the cart index UI. Copy that and paste it right here. It will be purely HTML and CSS, nothing related to .NET Core. Now in the cart controller, we are returning back a cart DTO, so that will be the model right here. Before we modify and make this dynamic, let me run the application and see the UI in action. Let me log in here as admin, navigate to the shopping cart here, and perfect. We have some product details, but we have to be dynamic. Based on the number of product here, we will have to iterate or multiply this line. And we have a link to continue shopping. And right here, we have a link to continue shopping. I will add an action method there. It will take us to the index action of the controller, that is the home controller. We move down here. We need to display the image right here. Well, let me see, I'm not missing anything. Yep. First, we need to display the image. But that particular div, we will have to iterate multiple times. I will add the for each loop there. I will say variable cart obj in model dot cart details. Now where will be the closing tag? Let me find that right here. We have the image that will be inside cart obj dot product dot image URL. We have the product name here that will again be inside cart obj dot product dot name, and we have the description. We will have to convert to HTML dot raw, and that will be cart obj dot product dot description. We have price of the product here. I will convert that to the currency format that will also be inside the product obj. And finally, we have count that will be inside cart obj dot count. I will scroll down. We have an anchor tag here to delete item. Let me call that ASP action is equal to remove. When we are deleting anything in the shopping cart, we have to pass the cart detail ID. We will pass ASP route. Call that the same. Cart detail ID is equal to, and that will be cart obj dot cart details ID. Let me call this cart details ID, and perfect. That looks good for the cart detail. Let me go back here, and that does not seem to work. Let me go back here, add a debugging point here, and see what we get back. We have a response DTO. Based on that, it should have iterated. Something is not right here. Let me restart application to be sure before we spend time in debugging. Let me log in as admin here. Navigate to the shopping cart. It hits our breakpoint, continue, and there we go. We had to restart the application, but now we see both the product. If I click continue shopping, it takes me back to the home page. Let me continue to work on this in the next video. Let me continue working on our shopping cart here. We need to display the order total and discount total. Right now in our shopping cart, we have not applied any coupon. Before we work on the order total, let me work on adding the logic to apply coupon and also delete any item from the shopping cart. Let me go back to the code here, where we have the apply button right here. In that button, let me add the ASP action of apply coupon. So we have apply coupon here, and then if we go to the top, we have the form tag without any action. So when we hit apply coupon, it will go to this particular action. When we are deleting any item, it will go to the remove action. Let me create them in the cart controller. Let me work on the simple one here, which will be remove. I will create public async task of I action result. Method name will be remove. And what is the integer ID that we receive here? If I go back, copy that name, paste it right here. We need to get the user ID. Let me copy all of this, paste it here. For the constant here, you can use the JWT claim type, or we have the JWT registered claim name. We will retrieve the user ID. On the cart service, we have remove from cart async, and there we need to pass the cart details ID that will remove the shopping cart. If everything is successful, we will redirect them back to the cart index. So return redirect to action, and we will redirect them to name of cart index. Let me add a temp data here for success. I will add a message, cart updated successfully. If there is any error, let me return back to the view. Perfect. That looks good for remove. Next thing that we have is apply coupon. I will copy and paste that here. We have the apply coupon. The name here will be apply coupon. That will be an HTTP post here. And there we will get the cart DTO. When we are applying the coupon, we need the user ID as well. But we already have that user ID on the cart index. So in the form here, let me add two more hidden properties. One for the user ID and next one for the cart header ID. That way when the form is posted, user ID will automatically be populated. On the cart service, we have apply coupon. We will have to pass the cart DTO. With that in place, let me add debugging point on apply coupon and remove here. And let me examine the user ID to be populated. I will have to restart the application. Hot reload for some reason is not working again, and it is a blessing when it works, but right now also it is not 100%. Let me log in as an admin here. We go to the shopping cart here. For some reason the IntelliSense here is not working. That's okay. Let me apply the coupon 10 off. Apply that and examine the cart DTO. I need the user ID to be populated. That is great. If I continue here, continue there, it says cart updated, but I do not see the coupon. Let me validate in database. And you can see that did not work. Something is not valid. Let me try that again and debug to see what is going on. Let me examine the response here. It says that was successful. I will have to do a little more debugging. In the cart API, where we have apply coupon, add a debugging there, and I will add a debugger in the base service. Right here. Perfect. Let me continue. And let me try that again. 10 off. Apply that. F5. And let me examine the message. It is going to API cart apply coupon. That seems right. It goes to the apply coupon. So cart API is being invoked. That is good. It retrieves the cart from the database. And for some reason the coupon code is not available right here. So cart header.coupon code is null, and that is the culprit. Debug. Let me disable all the breakpoint and continue. I believe we are forgetting something in the cart index where we have the input field. Let me see. Yes, of course. We do not have the ASP4 here. That will be cart header.coupon code. Simple as that. We will have to restart the application. Auto reload is not working. Let me go to cart and try the 10 off. This time it should work, and perfect. You can see cart updated and we see the coupon right here. Let me try to delete something from the shopping cart, and that also works. Perfect. That is great news. Now let me display the order total and order discount. We have the order total here. I will display that in a currency format, and that is inside model.cartHeader.cartTotal. Where we have the order discount, we will display that only if the discount is greater than 0. I will add the if condition if model.cartHeader.discount is greater than 0. Only then we will display the order discount. And we will have the currency format model.cartHeader.discount. Let me save that. And then where we have the button to apply coupon, if a coupon code is already applied, we need to display button to remove the coupon. So let me add an if condition here. If the coupon code is not null or empty, we will display apply button. In the else part, I will copy all of them, paste it here, but the button action will be remove coupon. Add that here, and the coupon code will be disabled. I will call that remove here, and let me add that endpoint. Where we have apply coupon, let me copy this, paste it once again, for remove coupon, and there we will set the cart DTO.cartHeader.coupon code to be empty. With that, let me restart the application and make sure that everything is working as expected. Let me log in here, and if I go to cart, we have 10 off. Discount, you can see we have $10. Remove that. Perfect. That looks good. Let me try to add few items to the shopping cart here. That is working. And perfect. If I do 20 off now, that works. Remove that. Invalid code. You can see it applies that, but the total stays the same. So that is on user if they want to enter a valid coupon or not. I do not have the button text here. Something is not valid again. Let me scroll down, and of course, let me remove the value here, add the closing tag for button right here. Hot reload will not kick in, but our cart is looking great. Let me continue from the next video. Now let me stop the application and let me close all the tabs that we have open. Then inside the coupon API, let me open the coupon API controller, and if you remember, we commented out the authorized tag right here. Because what was happening is when the shopping cart API was calling the coupon API, we were not passing the bearer token from the shopping cart API. If I run the application right now, we will see an exception. Let me log in here. And then if I go to cart here, we get the exception right here. Now of course I can overcome that by checking if response is not null, and if response is success, then return back, else return a new coupon DTO. That will work, but again it is not a solution, because with that, let me run the application and try to apply a coupon code. Let me log in here. And if I go to cart here, even though 10 off is applied, you can see the order total. We do not see the discount. And that is because our shopping cart API cannot access coupon code because it has to pass the bearer token. How can we pass bearer token that we already have in the shopping cart API to the coupon API when we are invoking that? Now that is a little bit advanced concept, but let me walk you through that. Here I will create a new folder. Let me call that utility. In that utility folder, I will add a class file, and I will be pretty explicit on what it is. I will call that Backend API Authentication HTTP Client Handler. Now that will implement the delegating handler. Now you might be wondering, what is a delegating handler? Delegating handlers are kind of similar to the .NET Core middleware, but the main difference is that delegating handlers are on client side. So let's say if you are making an HTTP request using HTTP client, we can leverage the delegating handler to pass our bearer token to the other request. And that is exactly what we want here. Now bearer token, we can retrieve that from the context accessor. So let me inject that with dependency injection. Then here we have a protected override send async that we can override to access the token and add that authorization header. We will not remove the send async because that will continue the flow, but before we continue, we want to get the access token and add that to the authorization header. We will get the token here by await on the accessor. We have HTTP context dot we have a method get token async, and that will get the token using our default authentication scheme, and the name here must be access underscore token. That is where the token will be stored. Once we get the token on the request dot headers, we want to add the authorization, and that is new authentication header value. Let me add the using statement. We need to pass the bearer token there. Let me do that. Perfect. That looks good. Let me await here. And with that, we need to register the backend API authentication handler. I will do that in program.cs file. Right here, I will say builder.services.add scoped. We want to add the backend authentication HTTP client handler. And on top of that, we are injecting the HTTP context accessor. Right here, let me add builder.services.add HTTP context accessor. Now here we have added the backend API authentication handler that we created. But when we are registering that to the service, at that point we have to add the HTTP message handler. So right here we will say add HTTP message handler, and what is the implementation for that delegating handler? That is our backend API authentication HTTP client handler. That will make sure that it will add the token, and I will pass that for both product API and coupon API. With that, let me save everything and run the application. Now again, delegating handler is a complex topic. You can research it a little more, but I have given you a brief overview on how to use that. Let me go to cart here. And perfect. Now you can see the discount order is visible and we can see the order discount. Our shopping cart is looking great now, but if I log in with a new account, let's say customer here, we do not have anything in the shopping cart. If I click the shopping cart, we get the exception. We have to make sure when we are iterating through each of the object here, we need to have items in the shopping cart. In order to fix that, let me zoom in a little bit. Right here, I will add an if condition, if model.cart header, if that is not null, and model.cart details dot, we have the count here. If that is greater than 0, only then we display the form. Let me close that right here. Else we will display please add items to the cart. Let me run the project again and see if that works. Let me log in as customer here. Navigate to the cart here. Perfect. Please add items to the cart. If I add an item, great, that is working. Now if I apply 10 off here, it will apply the coupon, but you can see the discount is not applied because we have the constraint that minimum should be $20. You can see 10 off has a minimum amount of $20. If you add one more item to the cart here, then the discount is applied and perfect, that is looking good. When we are programming, we have been adding API methods and we have used await and async in many of the methods. But this async and await is different than asynchronous microservices communication. And the reason behind this async and await is when you are using an await key with any of the methods, you are basically telling that your thread must wait at this line until a response is being returned from the create update cart method that you see in the example. That means that if a particular method takes 20 seconds, the execution will not go to the next line until 20 seconds are passed and a response is returned back. In that terminology, even though we are using async await, it is kind of synchronous communication because until and unless that execution is not completed, the flow will not jump. But if this was an asynchronous communication, then the line will be executed and it will not wait for the response. But because we are using the await keyword, we are telling that you must wait for a response before you move forward. That makes it synchronous communication. I hope this makes sense to you and you do not confuse yourself saying that we are already using asynchronous communication with the await keyword. Now you might be scratching your head on what exactly and how will we implement asynchronous communication with microservice. Let me walk you through that in the next video. In this video, I want to give you a brief overview of synchronous and asynchronous communication. Synchronous communication is basically communication when clients sends a request and server responds back before a new request is sent out from the client. This is a straightforward approach in a typical application. But when we are using microservices architecture, it is possible that one service wants to call multiple services on one action without waiting for a feedback. That is not possible with synchronous communication because with synchronous communication, they always wait for a feedback from the server and only then move on to the next request. One positive thing about synchronous communication is that there is always a feedback or acknowledgement of the request being completed. But at the same time, that might not work with some situations in microservice communication. On the other hand, we have asynchronous communication, and that is when client does not wait from a response to the server. Basically, client will send request and then it will assume that request will be taken care of from that point onwards. It does not wait for an acknowledgement on if the request was completed or not. Because of that, in asynchronous communication, parallel service calls can be done at the same time since we are not waiting for any feedback about the request completion. Now let me switch back to an example with the first one, that is synchronous communication. Now there are some disadvantages with synchronous communication. Let me assume in the architecture here, our web project is sending an email functionality where the email service has to send an email. But for some reason that logic is taking way longer than expected. If it was synchronous communication, then the web page will be spinning continuously, waiting to get a response back from the email API. But if this was an asynchronous communication, then it does not care about the feedback. And that is typically the scenario when we work with emails. We tell them that, hey, this is the email address, this is the content, you should send out an email. And that's it. Once we send that message, we are done with that and we move on to the next line of execution. When email service will have time or when it will receive that message, it will start processing that and it will send out an email. That is a functionality that user or front end should not wait on while the email is being sent. In that case, only thing the sender is responsible is to send a request and forget about what happens with that request. Now you might be wondering where we have synchronous and where we have asynchronous communication in our architecture. Where you see the solid lines between microservices, those are synchronous communication and we will wait before we return back the response. But where you see the dotted lines here, all of them are asynchronous communication and we will not wait to return a response back. An example of synchronous communication is when we are on shopping cart and we have to load all the products. We cannot return a response back of shopping cart without loading the product details. In that case, the shopping cart API will wait for a response from the product API. Once it gets the response, it will build the complete model and return back. And then an example of asynchronous communication is when we are sending out an email. Once an order is placed, we will tell our service bus that, hey, we need to send an email and we will move on to the next execution. We will not wait until the email API picks that message and actually sends out an email. Main point to remember here is the order API will not wait for a response from the email API or wait till the email is sent. Customer will place the order and continue to browse the website, and email will be sent later when the email API processes the message. That means the order microservices is not dependent or waiting until the response is received from the email API. It will deliver the message and move on to the next task. That is an example of asynchronous communication. We will be implementing all of that, but I wanted to give you a brief overview and a general idea of how synchronous and asynchronous communication are different. Another functionality that we want to implement here is email cart. What that functionality will do is it will typically send an email of the shopping cart. Now we will not be sending an actual email because for that we will integrate SendGrid, and there are some complexity if you are learning with a personal email. What I will instead do is when we hit the email cart button, we will have a separate service that will be responsible for sending out all the emails, and in that service I will actually log the data inside a database. That way, if you have to process email, you can retrieve the record and send email. But sending email is not something I want to cover in the course because it is more prone to errors, and it also depends on what email sender you are using for your project. But I have given you a hint here that we will implement an email service that will be responsible to send all the emails across the project. Not only one service, but it will be responsible to process all the email. Before we look into that, let me open the architectural design that we have. When we were working with shopping cart, we used to retrieve coupon and we also had to retrieve product. Those services cannot be an asynchronous service because when someone wants to load the shopping cart, we need to instantaneously get a response back from the coupon API and product API to display the shopping cart. But now think about email service. When you are working on sending an email, it is okay if an email is sent out in 2 minutes or even 3 minutes. Typically, you do not have a constraint that you need to send it right away or else it will not work. And based on that, you can see our shopping cart does not directly integrate with the email service. We will have something called a service bus, and that is basically a place to store some messages. What we will do is on the button click, we will add a message in the service bus with all the content that email service will require. What service bus will do is it will capture that message and it will forward that to the email service. Email service, when it receives that message, it will start processing and it will log that email in the database. The advantage of that is, let's say email service goes down for some reason. In that case, the message will be preserved in the service bus, and when the email service is back online, it will start processing all the messages that are there inside the service bus. Service bus is provided by Azure, that way it integrates well with the .NET framework, but there are also other message broker services like RabbitMQ and much more. First thing that we have to do is we need to create service bus, and when the button is clicked, we need to send some message inside our service bus. We need to create something special, that is service bus. How do we get started with that? Service bus is provided by Azure, so you need to go to portal.azure.com. If you do not have an account, make sure to sign up for a free account. You get about $200 in credit with the first time sign up. On my home page here, I can see the service bus. But if you do not see right here, you can search for that right here, and we have service bus. I already have one service bus, but we will create a new one for our project. Similar to any other resource, you will select a subscription and a resource group. I will select .NET Mastery Live Project, and then service bus is something that is always online, and that will be hosted at a URL you can see it is .servicebus.windows.net. We have to give our service bus a unique name. I will call that Mango Web here. You can select the location and we need to select the pricing. Based on the pricing, you can see basic is super cheap. But with that we have some limitation. Let me click the browse here to see all of that. You can see in basic we only have queues. But when we go to standard, along with the queue, we also get topics. Now what is difference between them? We will cover them in upcoming videos. But let me select standard here because down the road we will be exploring topics. With that, let me hit the review plus create button. Validation is successful. Let me create that. Perfect. Deployment is complete. Let me click on go to resource and perfect. We are on the Mango Web Service Bus. If you go in Service Bus, we have the Mango Web right here. Inside there you can see there are two things in entities. We have queues and we have topic. Let me walk you through them in the next video. Now that we have a basic overview about queue and a topic, let me create a queue. We will go to queue here and hit the plus button. We will give that a name of email shopping cart here, and we have few properties that we can configure. Max delivery count is 10, but we can keep that as 5, that is okay. Now queue size, you can keep that whatever you want. 1 GB is way more than enough for our requirements. Next, there is message time to live. That basically determines how long the message will stay in the queue before it is expired. For some reason, if the service that is reading messages from the queue, if that fails, then it will hold the message in queue for 14 days. Then we have lock duration. Let's say there are more than one receivers for a queue. When we are in the queue, if a message is delivered to one of the receiver, then it is locked for 1 minute. After that, it can be sent to the other receiver. You can toggle that time if you want. And then we have some other features here. And then we have many other advanced features like forward message to queue or topic. In that, when a message is received in one particular queue, do you want to automatically forward that message to other queue or topic? If you click that, you have to select an existing queue or topic. We do not want that. We will keep things simple for now. Let me hit the create button and let me create our queue. And perfect. With that, our first queue has been created. If you click on the queue name here, we have a Service Bus Explorer there. There you can examine if there are any messages in the queue already. You can see right now it is 0. Dead letter basically means that those are dead messages. So if something does not work after the 5 delivery count, it will automatically be moved to dead letter. Now we have our queue. My goal is when we hit the email cart, I want to configure a message and write that in the queue. For that, we need to create an integration service where we can call some method to post some message in the service bus topic inside the service bus queue that we created. Now I want to implement a service where we will be able to send a message in our service bus queue. Let me stop the application and we will have to create a new service. That I will do inside the integration folder. Add a new project. It will be a class library. Let me search for that and let me create that. I will call it mango.messagebus. Let me hit the next button. Looks good. Perfect. Now the default class, I do not want that. I will remove that and I will select manage NuGet packages. When we are working with service bus, we have a NuGet package for that. So let me search For service bus, we have azure.messaging.servicebus. You can see in the description here, Azure Service Bus is a fully managed message broker. And using the package here, we can send messages to our service bus. Let me accept and add that. Perfect. In the project here, I will add the interface. That will be iMessageBus. And its implementation will be inside the class MessageBus. Let me go to the interface. It will be a public interface. And there I want to create one method. It will be an async method. And I will call that publish message. What will be the parameters? If you think about that, when we are publishing something to the queue, we need the queue name and the message that we have to publish. We don't know the type of the message, so we will keep that as object, and we need the name. That will be string. I will call that topic underscore queue name. Because we don't know if it is a topic or a queue, when we are publishing the message, the logic will be the same. The only thing we want here is topic or queue name. With that, you might be wondering that can I have the same name for a topic and a queue inside the same service bus? The answer is no. If I go back to the code here, we have email shopping cart in our queue. Let me copy that. In topic, if I try to add the same name, it will not work. So name must be unique between topic and queue inside a service bus. With that, our interface is looking good for the iMessage bus. I want to implement the message bus right here. Let me make that a public class that will implement the iMessage bus. Press Ctrl dot and implement the interface. When we have to send a message to service bus, we will basically await, add a using statement, create a variable client, and that will be new service bus client. That is inside the using statement of azure.messaging.servicebus. Let me add that, and in the parameter, we need connection string for our service bus. If I go back to the portal here, let me go to Mango Web, and right there we have the shared access policies. We have the root policy here where they can perform all the operation. If you want a new policy, you can of course create a new policy with whatever access you want, but the default one is good enough. We have the connection string here. Let me copy that and I will paste that in a string right here. Private string connection string is equal to, paste that. Now typically what you will do is you will have the connection string in app settings of the individual microservice. And then when you are invoking, you can pass that as a parameter. But for our microservices project, we will only use one service bus. That is why I am hard coding that here. But I wanted to point out that ideally, you will place that in app settings, pass that down as a parameter, or maybe you can have this message bus service in the microservices as well, rather than a separate project. You can decide that architecture based on the complexity you have for your project, but I am keeping that as a shared project. That way we will simplify few things. Now here we need to pass that connection string. Let me pass that. And with that we have created a client on the service bus client. In order to send a message, we have service bus sender. Let me call that as sender is equal to. On client, we have to create a sender. And when we create a sender, you can see it expects a queue or a topic name. We have that in the parameter, which is topic underscore queue name. We can pass that. Before we append the message here, it makes sense to serialize that. So variable JSON message is equal to JSON convert. Let me install the NuGet package for that. We have the serialize object, and we want to serialize our message. The message that we will send will be of type service bus message. Let me call that final message is equal to new service bus message. And there we can define encoding UTF-8.getBytes. We want to pass our JSON message right there. We want to pass our JSON message there. On top of that, I want to add something in the parameter here. That is a correlational ID. It is basically an identifier. And I will generate GUID.newGUID.toString. With that, we have configured the final message, and that will have the JSON message that we want to convey. In order to send that message on sender, we will call the send message async and pass the final message. Once everything is done, we will dispose our client. So client.dispose async. That way we are able to publish message to our service bus. We want to publish our message, and there we want to pass our shopping cart. If I go back to the service here, where we have the shopping cart API, inside the cart API controller, let me create a new endpoint to write some message in our service bus. Let me scroll down here, and let me copy this HTTP post, paste that one more time here. I will call that email cart request. That will be the name, and from body we will receive the cart DTO. That will be the message that we want to publish. Let me remove everything else here, and in order to get the message bus, we will have to configure our program.cs. We have the scoped services here. I will add iMessage bus, but if you press Ctrl. You cannot find that. We will have to add the project reference here, add, and we have project reference. We want to add the message bus. Let me do that. And now if you press Ctrl. Perfect. We have the using statement. Let me close everything else here. And in the cart API controller, we have to add that using dependency injection. Let me add that. Perfect, that looks good. I will scroll down. Not cart absurd. We have the email cart request. There we will say await underscore message bus dot. We have the publish message, and that expects two things. First is the message that we want to publish. That will be the cart DTO. And next we need the queue or topic name. We can have a magic string here with the name. Let me go back, that is email shopping cart. But that is not ideal. Ideally, it would be inside the app settings.json file. There, let me create a new section with the name of topic and queue names. Key will be email shopping cart and value is email shopping cart. Now the value here, make sure it is exactly the same without any spelling mistake. We need to access that from our app settings. We need the iConfiguration and dependency injection for that. Let me inject that here. And we have the underscore configuration. Let me scroll down. In order to get that here on configuration, we have get value. We will define the type here. And then what is the section name? Let me copy that to avoid any spelling mistake. That is topic and queue names. Go back here. Key name is email shopping cart. Make sure to separate them with a colon here. And that looks good. With that, it should be able to post a message to our service bus. The only thing that we have to do is invoke this endpoint from the web project. Let me close all the tabs here and open the web project where we have the cart services. Let me minimize everything else to avoid confusion. Cart service and iCart service. I will add a new method here, call that as email cart, and let me implement that. When we implement, we have to post, so let me get that and paste it here. We will get the cart DTO, make that an async here, and we need the method name. Let me go back to the API, cart API. Method name is email cart request. Copy that and paste it right here. That looks good for the cart service. Close all of this here. Open the web project. Inside the controller, we have cart controller. Let me open the cart index view and scroll down where we have the button email cart. We have one button here, so what we can do is go to the top where we have the form. I can write ASP action here and let me call that email cart. Then in the controller here, we will have to create that endpoint. Let me copy the apply coupon, paste it one more time. That will be email cart. We will receive the cart DTO, and on cart service, we will invoke email cart. If that is successful, we want to display the message email will be processed and sent shortly. Because what will happen is right now it will post message in the service bus. We have not written the API that will read messages from the service bus and process all email requests. That will be done shortly. But right now with all of that, let me start the application and see if that works. We go back while the application is running and open the cart API controller where we have the new endpoint. Let me add a debugging point and go back to the web project. Let me log in here as an admin. Let me go to the shopping cart and click the button email cart. Perfect. Let me examine the cart DTO here. We have everything with the cart header, but cart details is null. We can still publish the message here. Perfect, we see that. Let me go to the Azure portal and where we have the email shopping cart. If we click on the Service Bus Explorer, perfect. You can see there is one message in the queue and we can peek that message. There we have the cart header. Cart details is null, I will fix that, but you can see our message was posted successfully. In our cart, we need to populate the cart details. But on top of that, we also need the email address. That way we know that where this email should be sent to. Now if we examine the cart model, let me go to the web project where we have the cart DTO. Open that here in the cart header. We do not have anything to store email. In the future, when we place an order, we might have more details like what is first name, last name, phone number, email, and there might be more things that you want to capture. We can always add them in the cart header. I will make them optional for now, but if something changes, I will come back and modify that here. Let me add that in all the cart header DTO. Let me search them here. Cart header DTO, and I will paste it right here as well. Perfect. Now let me go to the cart controller in the web project where we have the email cart. Rather than using the cart DTO in the parameter because we might not have everything, I can retrieve the cart DTO using await. We have the method load cart based on the logged in user at the bottom right here. We are getting user ID based on the subject here. Let me copy that and I will populate the email address right here. For email, we have the JWT registered claim types.email that we populated, and I will add that in cart.cart header. Now we have the property to store our email. When we are calling the email service, make sure to call the cart object. That way it will be populated with all the records. With that configured, let me restart the application and try that once again. Let me go to the web project. I will log in again as admin. Navigate to cart, and we have email cart. We hit our breakpoint. Let me remove and continue. And perfect. Let me go back to the Azure portal. And if I refresh here, great. Now we have two messages here. And perfect. In the second one, you can see we have all the details about shopping cart, and that is much better. Based on this object, now we can deserialize that in a different email API and log our shopping cart in the email table. We have to implement one more API that will be responsible to read all the messages from the service bus and process or log the email that we want. That will be a simple API, but let me do the basic foundation that we have for the other API as well. Minimize all of this here, and I will stop the application. Create a new project, ASP.NET Core Web API, call that mango.services.email API. Let me copy everything from the product API. We will start by the NuGet packages. Copy that and paste it right here. Perfect. Next, what we have to do is add DB context in the email API. Copy the data folder, paste that here, and I will update the namespace here to be email API. We do not want to seed any data there. Let me remove that. In the models, let me create a model to log all the records. In the models folder, add a new class file. That will be email logger. And it will have 4 properties: ID, email, message, and date time for the email sent. That should be good enough for now. We want to keep that super simple. Email logger. Call that email loggers. We need to configure the app settings. Let me copy that. Copy the connection string. We do not care about API settings or authentication in this API endpoint. Paste that right here. The database name will be mango_email. Let me remove the weather forecast controller. We do not want them and the model as well. And I will open the program.cs in the product API where we have the default connection. Copy that and paste that in the email service. Add the using statement. And we do not need anything with authentication or auto mapper. Let me scroll down. Copy the apply migration. Paste that here. And invoke that. Finally, let me edit the project file here. Remove the invariant globalization. And let me add a migration. That will be API project, add migration, add email log table. Perfect, that is done. Let me set that as a startup project and run that. And once we run that, it should create the table. Let me see. We have Mango email with one table, email loggers. Perfect. With that, we have set up the base requirements for our email API. But before I end the video, the model that we receive here is a cart DTO. To deserialize and read the content, we will require a cart DTO in our project. Let me copy and paste them as well from the front end here, models. I will copy cart DTO, cart header, cart details, and paste them in the API models. Let me create a new folder for DTO and paste there. Update the namespace here to mango.services.email.api.models.dto. Copy that and apply that for all of them here. Perfect. If I build the project, it should work. Let me double check. And we need the product DTO as well. Let me copy that, paste it here, and modify the namespace. Perfect. We do not need any data annotation. Let me double check, and that looks good. Let me build the solution. Build failed again. Let me rebuild here. Let me try to run this. We have an error here. We forgot the closing bracket. There we go. And perfect. The API is functional now, and we have added the DTOs as well. In the email API, my main goal is to read the message that we receive right here and deserialize them. We want our email API to be notified automatically when there is a new message in this particular queue of the service bus. In order to set everything up, there will be a couple of videos, but let me do all of that right here. Minimize everything else. We are only working on the email API. I will create a new folder for that, and I will call that as messaging. In there, let me create a new class. I will call that Azure Service Bus Consumer. Name is self-explanatory here, but here we will be consuming the service bus and all the messages that are being sent. Email API will be the receiver of those messages. For that, we will require some configuration. One thing will be the connection string of the service bus. As I said before, the ideal approach is to store that inside the app settings. Let me create a key with the name of service bus connection string. Then I need another section here for topic and queue names. There we will store all the topic and queue names that we have created, and also one that we will create. If you navigate to the shopping cart API in the app settings, we have one topic and queue name, and we know that email shopping cart is actually a queue. So let me append the word queue at the end. That way it is more explanatory on whether that is a queue or a topic. I will also update that where we are using that in the cart API controller. Where was that? Right here. Whoops. Let me modify that, and perfect. Let me copy this topic and queue names and add that in the app settings. Now make sure that the app settings that you are adding is email API. I will double click that to be sure, and perfect. We have added our queue name in the app settings. I need connection string for the service bus. I can go back here, service bus, and shared access policies. Let me copy the connection string and paste that right here. Perfect. We have both the constant here, and we need to access them inside the service bus consumer. Let me create two constants here, and then in the constructor, we need to get the I configuration with dependency injection. Once we add that, we can populate our service bus connection string is equal to underscore configuration dot. We have the get value. We will define the type here, and then the key name. Let me go back here, copy that and paste it. Perfect. That way we will receive the connection string in the constructor here, and we also need to receive the queue name for email cart queue. Let me copy the configuration, paste it here. We have a section name there, and after that we have the key name. Copy and paste that, add a colon between that, and perfect, that looks good. Then we have to create a service bus client on the connection string. Let me add a variable for that, but in the email we will have to add the package microsoft.messaging.servicebus. We can install that right here. In the parameter we have to pass the connection string. Let me do that. Once we have the service bus client, now on that service bus, if we want to listen to any of the queue or topic, we have to create something called as a processor. Right now we want to listen to one queue, and that is email shopping cart. We will have to create a processor for that. We will say service bus processor, and I will give that a name email cart processor. Let me add an underscore there, and we need to set up that email cart processor is equal to client dot we have a create processor that expects a queue name or a topic name. You can see if it is a queue name, it is only one parameter, but if it is a topic name, then along with topic we have something called as subscription. Do not worry about that. Right now we only want to work on the queue name, and that queue name is email cart queue that we populated. With that we have configured a processor that is right now listening to the queue for any new messages that the queue has to send. But on this email processor now we have something called as process message async. You can see the implementation is mandatory here, and this handler is responsible for processing the message that is received from queue or topic. Let me implement that handler in the next video. We need to register our handler for the processor that we created. We can create a method here, but typically when we create a service, we will be registering that in the program.cs. So let me add an interface here. Let me copy the name first, and I will add a new item, interface, that will be Azure Service Bus Consumer. In here we will create two simple methods, start and stop. Both of them will be async here. Let me implement that right here. Azure Service Bus Consumer, implement interface. In the start here, on the email cart processor, we have the process message async plus equal to, we want to map a method right here. Let me call that method on email cart received. We have not created that yet, but I will do that very soon. Let me also register another method to the processor, but this will be in case of any error. How do we want to handle that? Let me call that method as error handler. Let me press Ctrl dot on the error handler, generate both of the methods here. Perfect. Now in error handler, we will receive process error event args, and that will have the error message that it encountered. You can log that here. You can send an email to someone if an error was encountered. I am only going to do a console.writeLine and return task.completed. But typically you will send out an email. That way you are notified when an exception is thrown or an error is encountered. Main thing that we care about is on email cart request received. This is where you will receive the message. When we receive the message, that will be inside args.message, and we will have to deserialize that. But before we deserialize that, we will have to do encoding.utf8.getString. we will get that from message.body. If I go back to the queue here, and if I examine the service bus, the model that we have here is a card DTO. Let me deserialize that here. Let me call that obj message is equal to, we will use JSON convert, add the package for that, dot deserialize object, and that will be of type card DTO. Perfect. Once we do that in a try catch block here, we can try to log email, and once that is completed, we have to do something like args.complete message async. That will mark or tell the queue that hey, this message has been processed successfully, and you can remove that from your queue. In the catch exception, you can throw the exception for now. Now try to log email. We do not have a service. We still have to add that service. Let me add a to-do for that. But that is great. We have configured the start method and we have registered our handler. That looks good. Let me cut the stop here, paste that here, and when we are stopping, we want to await underscore email card processor, stop the processing, and we will say card processor dot dispose async. With that, the start and stop is looking good, but we need to add that to the container and see how everything comes together. We have the start and stop, but when should these be invoked? The way I want to configure our API is when the API is running, start will be invoked, and if you stop the API, then and only then stop will be invoked. That means that API will constantly be listening to the queue for new messages. That is how we want to configure, and because of that, if you think about the lifetime with dependency injection, we can add that in a singleton lifetime. That way it will only have one copy. But we need to register the start and stop, and that we have to do that in program.cs. We have the application builder. I want to add an extension to that, and let me do that in a separate file. In the email API, let me create a new folder for extension. Inside there, let me create a class application builder extension. We want to add an extension, so that will be a static class, and that is on iApplicationBuilder. Let me call that as use Azure Service Bus Consumer. And for the extension, we have to use this keyword, and the first parameter will be the application builder. Now what do we want to register when the application builder is being configured? We want to add an implementation of the iAzure Service Bus Consumer. Let me copy that, and I will create a private static implementation, call that as Service Bus Consumer getter and setter. Let me add the using statement there, and perfect. Now here we need to get the implementation. On the app, we can say application services.get service, and we want the implementation of iAzure Service Bus Consumer. We are asking for an implementation here, but for that we need to register in the program.cs. Let me add builder.services.add singleton, and I will add the iAzure Service Bus Consumer and its implementation. And again, that will be a singleton lifetime because we do not want a new object for different requests. After that, we want an implementation of the service iHost application lifetime. That will notify us of the application lifetime, like when it started or when it stopped. So basically on the host application lifetime, when the application starts, we want to register a new method. Let me call that onStart. And let me copy and paste that again. Also, when an application stops, we want to add another method, call that as onStop. Let me create both the methods here. And then we are on the final piece. On start, we will start our service bus consumer, and when the application stops, we will stop our service bus consumer. Simple as that. We need to make this class static because that is an extension, and that looks good. Now here, do not forget to return back app. We do not want to hold the pipeline. Finally, we have to add that in our pipeline. So let me scroll down here and I will say app dot. We will add our extension method and add the using statement. Perfect. With that, it has been configured in the pipeline and it will automatically get up and running when the application starts. Now that we have configured the application extension to start our consumer, let me set the startup project as all the project that we have, including the email API, and let me see what happens. I will add a debugging point. Let me do that in the consumer. I have added a debugging point on the onEmail cart request received. That way we will know when a request is being received. Let me log in as customer here, and I will add item to the cart. Go to cart, click cart email. Perfect, that is done. And when we notice in the background here, and then if you notice in the background, nothing happens. It should have invoked the endpoint. Let me see, something is not right here. If I go back here and refresh, we have 3 messages. That basically means that our consumer is not working properly. It did not hit the endpoint when a message was there in the queue. Let me go back to the application and stop the application. In the Azure Service Bus Consumer, we are getting connection string, the queue. We have the processor creating that. On start, we are assigning the process an error. Whoops. Right here, we also have to start processing. That is a critical step. So basically, where we have the underscore email cart processor, we have to invoke the method start processing async. You can see in the description it says signals the processor to begin processing the message. So we need to invoke that. Only then it will start processing the message. With that, let me run the application again and see if we hit our breakpoint. We already have 3 messages and perfect. You can see it automatically received it here. Examine the message. The message that we are on is the first one with cart details as null. Let me see, deserialize that. And cart header, we have that. We mark that as complete. Right now the first message is complete. If we go back here and refresh, the queue is now 2. Let me continue here. Now it will receive the second message, and that should have header and detail. Looks good. When we complete message async, at that point the message will be removed from the queue. Perfect. So with that, it is processing all the 3 messages, and if I go back, the queue will be empty. That is great news. Now our consumer is able to consume all the messages in our queue, and now we can add some logic to log our email. But with that, you can see how everything is coming together. We are posting a message to our service bus queue from the API, and then a separate API with no direct relation is able to consume the messages that are being posted to the service bus. Now we need to send email inside the Azure Service Bus Consumer. The Service Bus Consumer is a singleton and the DB context is a scoped service. we cannot consume a scoped service in a singleton implementation. For that, we will have to get creative and get a new AppDB context implementation that is singleton. Before we do that, let me create a new folder in the email API. I will call that services. In that folder, I will create a class. Well, it will be interface email service, and the implementation will be email service. Let me make that an interface here, and that will have a simple method to send email. I will call that email cart and log, and that will expect a cart DTO. Let me implement that in the email service. We have the email service. Implement that interface. Here we cannot use the application DB context using dependency injection because that is scoped implementation. For that, we need to register an implementation for email service that is singleton. What I will do is first we will create a DB context option builder on the app DB context. Then on option builder, we can say we want to use the SQL Server and we have to pass the connection string. Let me copy and paste that. After that, on the builder.services, we want to add a singleton implementation of the email service. So when we get the email service, we want to pass the option builder.options. Once we have that, we will have to implement that interface in the email service. I selected that, so let me go to email service, and perfect. We have the DB context option that we are getting right here. Let me rename that to be DB options. The private here, I will call that underscore DB options, and we will have underscore DB options is equal to DB option. Where we have the function here, we will receive the cart DTO. From that, let me create a message that can be used as a template for email. I will create a string builder and I will append few lines like email cart request received, what is the total, and some details about the cart. Now of course you can get fancy with all of the requirements here, but I am keeping things super simple. Let me create one more method here that will be private, async, task, it will be a boolean, log and email. There we will receive two things, what is the message that needs to be sent and what is the email address. Let me add a try catch block there. In the catch here we will return false, else we will return true here. I want to create an email logger object and I will populate email and message. Mail sent will be datetime.now. Once we have that, we want to store that in the database. I will create a local variable underscore db that will be new app db context, and there we will pass the underscore db options. That will give us an object of the application db context, and using that we have email logger. We can add the email log and we will await underscore db dot save changes. You can use the add async here if you want, and that should work. But perfect. With that we are logging the email. Let me invoke that right here. Await log and email. We will pass the message and the email will be inside cart dto.cart header dot we have email. The message here we will have to convert that to string. Let me do that, and I believe that looks good. Finally, in the Azure Service Bus consumer, we have to inject the email service. And let me scroll down. Right here, we need to log that. So underscore email service dot email cart and log. We will pass the message. Let me await that. With that configured, let me run the application and see if that works. We have an error here. Let me see. I made a mistake there. We do not want the interface here. We want directly the email service that is registered with the singleton implementation. With that, let me run that and see what happens. Let me navigate to the web project that we have, log in here as admin, go to cart, we have few items, let me click email cart. Perfect, we hit the endpoint here. Let me go to the browser. We do not have anything in the queue because most likely it has already been processed. Let me go to the database, and great, it already logged that email cart and everything worked flawlessly. From the web project, it sent a message to our queue. Our email service received that message and it processed and logged that email. Now again, in a real world, you could have sent an email to the message and the email address, but you can work on the complexities there. Let me log out here and try customer for a second to see if that is working. Order total is $28. That worked here. And perfect. You can see we have customer@gmail, and that is also working as expected. I hope you guys have enjoyed the free video and you had fun learning the basics of microservices with .NET Core. Your journey to microservices has not come to an end. I have an advanced course on .NET Mastery where we will take the application that we built here and we will add on to that. In that course, we will explore how to place order and order management once the order is placed. I will be using Stripe integration for capturing real-time payments using credit cards, storing the session ID, providing refunds if they cancel the order, and order management, where we will have multiple status for the order. We will also implement role-based management that admin can manage all the orders and a customer can place the order and view the order details of their order. Then we will explore advanced concept in Azure Service Bus, where we will see what is a topic, what is a subscription, and what advantages they have when you compare them to queues in Azure Service Bus. We will also implement a new API for Rewards API, and where we have the image in product. Right now we are using a URL. I will change that to a file upload and make our product API more dynamic. That way it will be able to handle image uploads. Then I will introduce you to gateways and what role they play when it comes to microservice architecture, and we will implement an Ocelot gateway to see how everything comes together. Final step that I will do is deploy all the application endpoints that we build on Azure. That way you can see how easy deployment is. And then as a bonus content, I will also show you how to use RabbitMQ as an alternative to the Azure Service Bus that we have used throughout the course. So you can see there's a lot more to explore and learn, and I hope you will join me in the journey to learn advanced concepts with microservices. But before we see each other next time, please take a minute to like the video, leave a comment, and also subscribe to the channel if you have not done that already. That way you will never miss another update from .NET Mastery.